In the examinations, they are unlikely to ask you those simple kind of questions in the question papers, but what they do is they normally combine the question papers. They may combine tan with cosine, tan with sine, or sine with cosine, and sometimes they ask you about the points of intersections. Right, I think we must just pick one question here from the previous question papers and see how do they ask this question. I've got the preparatory exam 2008, and I want us to focus on question 6. And question 6, 6.1 says, express cos 2x in terms of sine x. That is a double angle. I believe you can just look at the back and get that 1 mark. That's an easy 1 mark. Now 6.2 says, without using a calculator, oh my poor calculator, I'm going to throw it away now, determine the general solution of the equation cos 2x plus sine x is equal to 0. Now, it seems to me that the examiner was kind enough to lead me in 6.1 by saying express cos 2x in terms of sine x. Why do I say that? When we solve the trig equation, we must try to establish that we've got only one trig ratio. In this case, we are having cosine and sine x. Now, cos 2x is a double angle that can be written as cos squared x minus sine squared x. Remember, cos 2x is the same as cos squared x minus sine squared x. But now, is this going to help us? We said we want to establish a single trigonometric ratio here. Now, cos 2x is the same as 2 cos squared x minus 1 if we use the double angles. Now the question is this going to help us? I don't think this is going to help us because we'll still have cos and sine there, because this is 2 cos squared x minus 1. And cos 2x is the same as 1 minus 2 sine squared x. Now you students, you are lucky enough, you are provided with this formula sheet where you can refer at the back. I hope I have worked for 20 years with this, so they've been printed in my mind. It's not easy for me to get them wrong. So through practice, you'll also do this. Now, it seems to me 1 minus 2 sine squared x will produce the same ratio here. Now, let's have that problem there. We have got cos 2x plus sine x equal to 0. We rewrite cos 2x as 1 minus 2 sine squared x plus sine x equal to 0. So everything has been expressed in terms of sine here. We can now make a progress. Now, this is a bit complicated if it stands like this. I'm used to a quadratic equation as ax squared plus bx plus c is equal to 0. I would like to relate this to that. Now I'll be having minus 2 sine squared x plus sine x plus 1 is equal to 0. You see, I don't like the value of a as negative, so I'll have to multiply throughout by negative 1. So I'll have 2 sine squared x minus sine x minus 1 is equal to 0. Now that I'm remembering about my algebra so much, can I use my algebra maybe to factorize this? Okay. I'm going to relate this. Say we are left with 5 minutes. We can quickly say let sine x be equals to k. Therefore, we'll be having 2k squared minus k minus 1 equal to 0. We try to factorize that. I'm sure you are comfortable with the factors. Factors of 1 are 1 and 1. The middle term is minus, so the big number should take the negative sign and the small number, and the other number should take, the small number should take the positive sign. It's small because 1 times k is 2k, 2k times 1 is 2k. So I factorize that, inviting my algebra, so I'll have 2 sine x plus 1 into sine x minus 1 is equal to 0. Then I'm having my format as a times b is equal to 0. Remember, in algebra, for this to be true, a times b is equal to 0 is either a is equal to 0 or b is equal to 0. So we use the same principle there. We take this one as a, this one as b, then we'll have 2 sine x plus 1 equal to 0, or sine x minus 1 equal to 0. Transposing everything, we transpose 1 to the right, then it becomes minus 1. We divide both sides by 2. We have got minus 1 over 2, and this one we have got sine x is equal to 1. Now I think we must stop right here. When we continue in the second session, we'll finish off with this problem here. Remember, I'll check your questions if you have sent the questions here. Thank you.